Okay, so we're going to look at simplifying radicals in this one, and that's basically the radicals we're looking at are square roots. So I'm going to start off with the first one. What we're basically going to do is, instead of, for example, square root of 27, instead of taking the square root of that and telling me it's 5.1, 5.2, whatever it comes out to, we're actually going to take as many whole numbers, as much of this number under the radical, the radicand, as many as we can out. Okay? So what I'm going to do is I'm going to factor 27. 27 is 3 times 9. When I see a prime number, I'm going to circle it. When I see a perfect square, I'm going to put a square around it. If everything is boxed or circled, that means you're ready to stop and proceed here. So instead of writing the square root of 27, I'm going to write the square root of 3 times 9. Same thing as 27, right? Then I can separate those, square root of 3 times square root of 9. What is the square root of 9? 3. What about square root of 3? Can't do anything with it, it's just square root of 3, so there is your answer. Now there's multiple ways to do this. Some people like to go all the way down to all the prime factors. So let's say I start off here and I go 3 times 9. And let's say I don't want to acknowledge that this is a perfect square. I want to keep going. I can still go 3 times 3, and now I've got all primes. So that means that the square root of 27 is actually the square root of 3 times 3 times 3. Now when you don't have a perfect square, you look for a pair. So I don't have any perfect squares, so I'm going to look for a pair of 3s. For every pair, one comes out. So that comes outside, and then the 3 here is left without a buddy, stays underneath. Now why do we pull these out with a pair? Well, 3 times 3, when you have a pair, that's the same as 3 squared, right? Aren't squared and square root opposite? So the square root of 3 squared is just 3, or you can look at it as 3 times 3 is 9. Square root of 9 is 3, okay? So that's 2 different ways you can do that one. So let's look at another one. Excuse me. Let's look at another one that we had. I know we had, we're going to run into this tomorrow potentially. So I'm going to do square root of, let's say, 72. Okay, square root of 72. First thing I'm going to do is I'm going to take the 72 and I'm going to factor it. Now, you try to find perfect squares. This is going to be method number 1. So I've got, oops, I can separate this into 2 times 36. 2 is prime, I'm going to circle it. 36 is a perfect square. So that means I can write this as the square root of 2 times 36, which is the same thing as the square root of 2 times the square root of 36. What's the square root of 36? 6. And then the 2 is left underneath. It doesn't have a buddy, so it's 6 square root of 2. Okay? Now, that's one way you can do it. It depends on how you personally want to do these. So we're going to look at a second way. We're going to factor it differently. So I'm going to do 72, and I'm going to do 9 times 8, because that's the most common pick. 9 is a perfect square, so I'm going to put a square around it. 8 is not prime, nor is it a perfect square, so I'm going to keep going. So I've got 2 times 4. 2 is prime, I'm going to circle it, and 4 is a perfect square. So the square root of 72 can also be written as the square root of 9 times 2 times 4. I can break that up into the square root of 9 times the square root of 2 times the square root of 4. What is the square root of 9? 3. What's the square root of 4? 2. Now I just multiply everything on the outside. 3 times 2 is 6, and I'm left with 6 square roots of 2. Same answer, right? Okay, let's look at even a third option. So let's say that's if you go all the way, that's if you still use prime and perfect squares. So let's do the last one here. I'm going to go 9 times 8, but I'm going to go all prime, everything down prime. So I'm going to factor out the 9 is 3 times 3. Those are prime. I'm going to circle them. The 8 is 2 times 4. So I'm going to circle the 2. And then the 4 is 2 times 2. So I've got all my prime factors now. I can't factor anymore. So the square root of 72, I can write as the square root of 2 times 2 times 2 times 3 times 3. Because that's what I have, 3 2's and 2 3's. When there's not a perfect square, you look for a pair. I've got a pair of 2's and a pair of 3's. And remember, for every pair, 1 comes out. And what's left underneath? 2. 2 times 3 is 6. And once again, what did I get for the answer? 6 square root 2. So it just depends on how you factor it, what you get, okay? And it's your preference. You can either use the perfect squares or you can just go prime. It doesn't matter, whatever's easiest for you. So let's look at one more example. Let's say we have one like this. If I can find my pen. All right. Make sure that I'm over here where y'all can see it. What if I have 4 times the square root of 40? Okay, now that's a little bit different because what have I added? Well, I've got that 4 in front. What do I do now? Well, first thing I'm going to do, you can't multiply what's outside times what's inside. Big no-no, can't do that. I'm going to ignore the 4 in front. And I'm going to do the 40 just like I would do the other ones. So 40. And I'm going to factor it all the way out to the prime. I've got 4 times 10. 4 is 2 times 2. Or you could do perfect square if you want to do perfect square. 10 is 2 times 5. So the square root of 40 is the same thing as 2 times 2 times 2 times 5. Okay? No perfect square, you look for a pair. I've got a pair of 2's, the 2 comes out. The 2 and the 5 both do not have buddies. So what you do is you remultiply them back together. So 2 times 5 is 10, okay? You multiply them back together. Now, for the square root of 40, I got 2 square root of 10. So what I'm going to do now is I'm going to take this 4 and I'm going to multiply it by that 2. So I can't multiply outside times inside. It's just going to be 4 times 2. So you'll end up getting 8 square root of 10 as your answer. And so that's how you do the ones with the coefficients. Okay? If you end up with everything paired up, that means that it is a perfect square. So for example, what if I asked you to do the square root of 81? And you say, okay, I'm going to factor 81. All right. And you get 3 times 27. And then you get 3 times 9. And then you get 3 times 3. So when you factor it, you're like, okay, the square root of 81 equals the square root of 3 times 3 times 3 times 3. But what happens? Pair, pair. For every pair, 1 comes out. There's nothing left underneath, is there? Everything's paired up. That means that this is a perfect square. It's just 9. There's nothing underneath the radical sign. And that's how you simplify radicals.